video is going to teach you how to do graphing, and we're going to do graphing practice number 1. The first thing I want you to do is pull out, this is on my website, hopefully you got this in class, and this is how to construct a line graph on paper. And we're just going to go through this, the 6 steps as we do graphing practice number 1. The first thing that I want to do is identify the variables and label the x and y axis. Okay, so my variables, usually in this first column is going to be the independent variable, which is the x-axis. And in the far right columns is the dependent variable, that's your data, and that's on the y-axis. Okay, so we can label those appropriately in just a little bit. Okay, now we're going to determine the value of each box for the x-axis and y-axis. We have to do this separately because we have different numbers. As you notice, our independent variables goes from 10 to 60. Our dependent variable goes from 2 to 4. So definitely different type numbers. The first thing you want to do is figure out if the data is spread out or if it's clustered. Okay. So for this one, I look at the first one from 10 to 60. That doesn't seem very clustered. So I am just going to pick my highest number, which is 60. Okay, this is my highest number. And I'm going to divide it by the number of boxes. If you count the x-axis, you'll find out that there's 30 boxes. Okay, so I just want to take 60 and divide by 30. That gives me 2. Okay, so each box can be worth 2. So when we do that in a second, this would be 2. This could be 4, and you'd go all the way up to 30, or up to 60. Okay. Now the y-axis are the ranges are a little clustered, but if you look down at the bottom, it's going to ask for a data point to predict from a 1 centimeter data point. Okay. So I'm going to go ahead and actually go from 1 to 4.3 isn't very clustered, but let's just go ahead and try that, okay? So let's call it clustered just so you can see that. When you have clustered data, you take your high number minus your low number, okay? And if you look down on number 7, we're going to have 1 centimeter, okay? That's going to be called extrapolation. Our high number here is 4.5. Okay, so 4.5 minus 1 is going to give us 3.5 centimeters. Okay, if I count the number of boxes, okay, the number of boxes, that number is going to be up the side is going to be 20. Okay, so our number is going to be 1.75. So you always round up. Okay, so this number is going to round up to a 1, a 2, or a 5. So 1.75, I'm going to round up to a 2. Okay, so this side is going to have a 2 as well. Okay. Your x-axis will be graphed like this. Okay, every box is worth 2. I didn't put all those numbers down because it just gets too jumbled up. And remember, the x-axis is the age of trees in years. Always put your units. Notice on the y-axis, we're going to start at 1. So I'm going to do my little double squiggle, and then my first one is going to be 1.0. So now this is the y-axis scale. Sorry, I just realized this should have been a 0.2. Okay, if you do the math on that, it's probably 0.175. Apologize for that. Okay, now the next thing I want to do is plot the points. You're just going to take your data table and look at the first line. So the age of the tree in years is 10. So I'm just going to take 10 and kind of follow it up. And then my average thickness is 2. So I'm going to put a mark where those two intersect, which is right there. Then just do that for the rest of the points. These are what your data points should look like. And if you notice, we shouldn't connect the dots. The dots are kind of got kind of a difference in the numbers. But you can see it looks pretty linear. So I'm going to add a best fit line, and I'm just going to do my best, trying to get through the middle of these things. And I'm going to make that my best fit line. It's just an average. You don't connect the dots. Now, number 7 at the bottom, it says, what tree age would you predict from a 1 centimeter annual thickness in the rings? Okay, so show your work on your graph. Okay, as we look here, this actually falls off the graph. Okay, so it would be, in order to get to 1, actually this one, you would predict that there would never be a 1 centimeter annual thickness. Okay. It just fell off the graph. So even at an age of 0, it's not on there. So you would predict that that would not happen. What annual thickness in the rings would you predict from a tree that is 25 years old? So all I do is just go, if I'm 25 years old, that's my x-axis. I'm just going to take this, and once again, I'm just going to follow it up. This time, I'm not going to find the dot. I'm going to go ahead and find the line and then read it on over, okay, which is just a little bit above that line. So that's 3.0, 3.2. I think it's between 3.2 and 3.4. So my answer would be 3.3 centimeters. Hopefully that helps. Feel free to look at this over and over. That's just kind of the process for graphing. Have a great evening.